I just had to like paste this thing. Yeah, because the data is so much. It's one, so I want to like I've done something. I've tinkered around with this data set before, so really know how know these features that are important. But it's not advisable for you to just find data set and so if features and just drop them, like try to remove it. Because also I'm trying to drop this. I'm trying to drop this like delete it. So what I'm saying that it's not it's not good in practice for you to just select anyone. You have to like to tinkle with it and all of that. You know the features that are really important for your prediction. So as you can see, like I added most of those non-null like that has very small non-null values inside inside these drop columns. I don't know how many they are, but yeah, and most of them also why I dropped them apart from they had the non very non low non values. Most of the features here, most of the features here, that's what we call in machine learning, what we call overfitting and underfitting. Overfitting means when you give the machine learning model too much data, too much data that it does not like struggle so much to learn stuff, to learn how the pattern actually works. It doesn't figure out you're making you're making it its life so easy. I'll just say yeah, just say that. You're making the life so easy for the machine learning model. Like so it doesn't need to like it doesn't need to like suffer itself to learn stuff. It just for example, um you're in exam hall and someone is showing you an expo instead of you to you're trying to write your exam, maybe you read for it but you came to the exam hall and it's an expo so you started copying. It was easy for you to copy, so what you read now will not be useful to you, so you're just copying something that someone has already done before, so it's not really useful, so you will not like understand it because you didn't strive so hard to learn it, so to write your exams. So I would say that's example left name of overfitting. The underfitting is the opposite. The underfitting is you not giving it enough data for you to figure out stuff. So overfitting is you giving too much data and too much information, and underfitting is not you're not giving it at all and making it so difficult for you to learn. So most stuff I moved here are uh, features that support that will ensure overfitting because this cell condition is actually for example now it's actually overfit because this cell condition now if the cell condition is actually high, if it's high or good, it means the price will go up, so you're kind of exposing the a very strong correlation to the machine learning model. So I just took it out because it is not it just made the machine learning model to be very robust because it already has it has something that it has one something that correlates with the sale price perfectly. So it's not really making sense. Even in when I do my machine learning models, once I do my correlation matrix and I see that the model correlates with the statistical value for like 0.8%, sorry, 80%, I will just drop the column because you're giving too much information. So this is one skill of a data scientist. You need to like know how to avoid overfitting and underfitting. But there should be a balance in it. Don't just not give the data so much and it does very badly, but it should be in between a little bit. So these are the columns I'm dropping. So well, we know this is a pandas object, so we need to call twin. We need to call twin equals to twin. This is a pandas function. Huh? So drop columns. Sorry, I did not quick create this. So you need to like compile it and run it so it knows where it gets it from. And this is the method. Then we'll do for the test also because for the test we also want to remove it for the test. So drop columns and as this equals to 1. As it means you're talking that you are the column level. So so play this so it works. So let's open our trend.info, and we have this. So we just have 28 data entries, data points now after 28. So we can see those values that had a little bit of small values, we took them out. So now we have filtered it more into narrowed the whole data space. So yeah, so I think we are good to go. So one other thing again, now we have narrowed it, we have taken off that one. We need to look at each of the features and then see how the distribution, because most of the features that you see here now, they are not numerical values, and we want to use them, so we have to like convert them into something that is numerical. So for example, this lot shape, not config, and we also have garage finish, and as you can see, it's an object, it's not an integer or a float value. So we also need to do something about it. So first of all, in pandas, there's also a method that we have in pandas. Uh, like this is just like we call an array. So this is, so let us copy this garage finish, for example. Since it is not an object, so let us see what is inside, what it entails, what it has in. So we call the value count. Um, drop now, drop any false.